Okay. Diagram shows graph of function given by that. All right, so the graph includes points 1, 3, and 5, 3, which are max points on the graph. Show that A is 2. So, well, they give us 3, -1 as well, which is a minimum. Okay, so we're going to have 1 plus, no, we're not. So, A, this is max minus min over 2. And find the value of B. I do not know why this is 5 marks. So we have 3 plus -1 over 2, which is 1. Guess take it. All right, B, gradient. So f at x is 2 sine pi over 2x plus 1. So the gradient is 2 cosine pi over 2x. The 1 goes away, but we have to multiply by pi over 2 because of chain rule. So that's just going to be pi cosine pi over 2x. The line y equals k minus pi x is a tangent line to the graph for 0 to 5. Find the point where the tangent makes the curve. Okay. So we know, okay, so if this is the gradient, we want this to be negative pi because that's the gradient of this thing. So if we divide by pi, that's going to be -1. Cosine is -1 here at pi. All right, so pi over 2x equals pi, and then just in case, every 2 pi, I'll put m, is another solution. So if we divide by pi over 2, pi divided by pi over 2 is 2, and then plus, and then we divide by pi over 2 again, which is going to be plus 4m, okay? So this is only good for 0 to 5, so we're going to have 2, and anything, so if m is -1, it's outside of 0 to 5. If m is 1, it's outside, so x is 2. And so this gives the point, so x is 2, so we have to find f at 2 now. So that's 2 sine pi over 2 times 2 is just pi plus 1. Sine pi is 0, so 1. So basically what we have here, just to review, the derivative at 2 is negative pi. Okay? That's what we found with all this. Okay? So now we're going to have, and the point on the graph at 2 is 2, 1. So we're going to have y minus 1 equals m, x minus 2. So if we do this all out, so plus 2 pi plus 1. This should be k. And the point where the tangent meets the curve is 2, 1. Should be. Okay, so, yeah. Now, solve the equation f at x equals 2. All right, so f at x is 2 sine pi over 2 x plus 1, and we want that equal to 2. All right, so if we subtract 1, that's 1, divide by 2, so 1/2 sine pi over 2x. Sine is 1/2. here, okay, at pi over 6. So here and here. So we're going to have pi over 2x. Okay, wait a second. I'm going to do it different. So if we want to multiply by pi over 2, that's still 0. And 5 pi over 2. Okay, so then we don't have to mess with the general form. Okay, so we're going to have pi over 6 is the first one. Then we're going to have 5 pi over 6. And we need to go all the way around to 2.5 pi. So we're going to have 13 pi over 6, because that's going to be 2 pi plus pi over 6. So now if we divide by pi over 2, which is multiplying by 2 over pi, we're going to have 1/3. We're going to have 5/12. Oop. So, no, we're not. 5/3, rather. And we're going to have 13/3. Okay. Last one. Ready for it. Okay, with the graphing calculator, we have to sketch the graph of G. All right, so if you go in the graphing calculator, you're going to have an asymptote at 0. But it's a pretty straightforward graph with just a minimum at 0.5. So that's basically it. 0.5, 2.33. Okay, find the derivative. So this is quotient rule, or you could do it product rule if you want, but whatever. So we start with v down here and up there, okay? So u is e to the x, du is e to the x, v is x to the 1/2, dv is 1/2 x to the negative 1/2. All right, so we're going to have v and v times the derivative of u, and then minus u times the derivative of v. I'm not doing anything more because they don't ask for it. Write down an expression representing the gradient of the normal. So if that's the derivative, the normal is going to be negative, flip it. So root x squared is that. And then I'm just going to write it nicer because I can. Minus e to the x over 2 square root of x. P is xy on G, and Q is that. Find the gradient of PQ in terms of x. All right, P is on the graph of G. Okay, so G at x, okay, is this. So the point is x, e to the x over root x. They don't want xy, they want it in terms of x. So this is P, and Q is 1, 0. So the gradient between P and Q is y2 minus y1 over x2 minus x1, okay? So I'll just erase that, and that should be the answer. Given that the line PQ is normal to the graph of G, so PQ is normal to the graph of G at P. Okay, so this is normal at P. So this is going to be equal to the normal. think it's going to be equal to this. Because, hold on. So this is the normal to G at point P. So if we, it's just X substituted in, it's the same thing. And then the line PQ, that gradient is this thing. So find the minimum distance from Q to G. Oh my. Okay. So we have the gradient in terms of x of PQ. So let's just say, PQ is like this. It's just a line. Because it's got x, y, and 1, 0. And then we also have it's normal to the so these are the same line. This and this are the same line. Sorry if I'm explaining this too much. Now, we need to find the x when that happens. So, well, the x and the y actually. So if we solve this for x, definitely in the calculator, and then we get that x and we sub it back in for y, we're going to have this point P and Q, and we can find that distance. Okay, so I put this in. This is, of course, the blue one, whatever. And then this one is the red graph. Yeah, they just simplified it a weird way. So I put it in like that, so don't worry about it. They simplified it that way. So I found the intersection. I found the solution. X is 0.545. And then that means that point P is the point that. And then when I substitute x into the y here, I get 2.336. Now I can do the distance formula, which is x1 minus x2 squared plus y1 minus y2 squared. Finally, you get 2.38. I don't like how they say the minimum distance, but whatever. That kind of implies you are having some optimization, but tough problem. I don't know if you'd ever see it, but that's that.